The next chapter that we deal with in chemistry is electrochemistry and redox reactions. In this chapter you can solve questions very easily if you write the equations properly, balance them well and remember all the formulas. So the first question that we have been given standard oxidation potential of Na2 plus electrode and the standard oxidation potential of Au3 plus electrode. We need to find out the EMF of this cell at 25 degrees Celsius. This is the anode in this cell and this is the cathode. So always for these type of questions, first write the equation at the anode. The equation of the anode becomes, at anode always oxidation takes place, always there is oxidation at anode. So this goes to Na2 plus 2 electrons. In an oxidation reaction, electrons are released from the system. At the cathode, the reaction becomes reduction, that is it accepts electrons to become reduced to Au. Now let us add these up. We always have to add redox reactions such that the electrons cancel. So we will multiply this equation by 3 and this by 2 to get our final equation as 3Ni plus 2 times Au3 plus gives us 3Ni2 plus 2 times Au. Also, the standard potential for the cell can be written as SRP of cathode, that is standard reduction potential of cathode, plus standard oxidation potential of anode. This can also be written as SRP cathode minus SRP anode. You can remember any of these formulas. This is standard reduction potential of an anode. Now let us use this formula. We have been given E naught Au, this is the cathode. So we have to first write SRP of cathode. Au3 plus is given to be minus 1.5 electron volt. But always keep in mind, whenever it is given, this E naught is given for the reaction of Au to Au3 plus, that is from left to right. It is always written in this fashion. Therefore, this is the standard oxidation potential. For finding out the standard reduction potential, this will be equal to minus of minus 1.5, that is equal to 1.5 volt. This is SRP. So we can write standard reduction potential of cathode equal to 1.5. And similarly for this one, we can add SOP of anode, which is clearly given to be 0.25. Therefore we add 0.25 volts. Therefore we get our E naught cell as 1.75 volts. Therefore now we have the standard potential for our cell, and our cell equation is this. Now let us solve it further. We know E naught cell is equal to 1.75 volts. Now we need to find out the EMF of the cell at this particular temperature with the given concentrations of aluminium 3 plus ion and nickel 2 plus ion, and we have the cell equation. So with all this information you can write the equation, the Nernst equation. This is equal to E cell is equal to E naught cell minus, the formula is 2.303 RT upon NF into log of base 10 the concentration of the products upon reactants. Now since these are in solid state, therefore we need not write their concentrations, which is constant. Therefore this will be nickel 2 plus whole cube upon aluminium 3 plus whole square. This is concentration of nickel 2 plus and this is concentration of gold 3 plus. So now you should also remember that this N is the number of electrons which are cancelled while forming the cell equation, which is 6 in this case. So we will write 6 over here. This is not aluminium, this is gold, Au. Now in this question we need this value 2.303 into RT upon F. You should remember the value of this. R is a constant, F is a constant, and for temperature is equal to 25 degrees Celsius. Particularly you should remember the value of this term, that is comes out to be 0.059. So the equation reduces to the EMF of the cell is equal to 1.75 minus 0.059 upon N, where N is 6, into log of base 10. We have concentration of nickel 2 plus to be 0.1, that is 10 raised to minus 1 whole cube, that is 10 raised to minus 3 upon, this is 1, therefore 1 whole square is 1. Therefore we write 10 raised to minus 3 over here. Therefore minus 3 comes outside and we get plus 3 into this quantity. So final answer for E cell comes out to be equal to 1.7795 volts. So final answer for the EMF of the cell comes out to be 1.7795 volts. So you should remember this important formula, that E cell is equal to E naught cell minus 0.059 upon N into log of base 10 products upon reactants raised to the power their respective coefficients, and this equation is true at 25 degree Celsius. Otherwise this term, the value of this term is 2.303 into RT upon F, and so we get our final answer as 1.7795 volts.